I'm absolutely delighted now to be joined by Eva Schmid from the University of Berkeley, and we're going to talk about a great program. We're going to talk about CellScope. Eva, welcome.
Thank you. Thank you for having me.
Thank you for talking to us today. Now this all looks fantastic, doesn't it? Tell us a little bit about CellScope.
So yes, I'm a postdoc in the laboratory of Professor Dan Fletcher in the bioengineering department, and I normally work on synthetic biology, but as a side project I got involved with CellScope, and this project was, it's ongoing since 2006 when Professor Fletcher posed a question in his optics class to the students of if they just had a bunch of optics and their cell phone, how could they make a microscope? And the idea was to use the camera of the cell phone to capture the image. And then attaching that to just very simple optical train, you can really have a very nice small microscope. And that is what CellScope got developed in. So from this very original project, we branched out in very many different directions. And the original idea was to use it for disease diagnostics in developing countries. Because in countries like Vietnam or India, the Congo, all countries we are actually collaborating with, there is a need of doctors, and there aren't that many around. So people with diseases like malaria, tuberculosis can get diagnosed in their village. Ideally, that would be the idea. And the image of a blood smear would be sent to the nearest hospital, where a clinician then would diagnose and send back the information and tell the patient what to do, if they need to come in or not. And so from that also we realized that it has a great potential in field research because it's mobile, you can take it anywhere, and with the explosion of network coverage all over the world, it's very easy to use cell phones to transmit information.
And good for education as well.
Exactly, so that was really more a chance encounter. So Oliver Hurler at UCSF worked with a high school or middle school teacher, Saba Khan, a year previously. I think that was now 3 years ago. And Sabar had the idea to bring scientists into his classrooms to teach about science that's ongoing at this very moment. So Oliver and I both came to his classroom, and since we are working on microscopic scale science, we thought, why not bring a CellScope and show them right there how it's how small things look that you can't see to the eye.
Bet they loved it, but why don't you show us, because it looks fantastic here. How does it work?
So yeah, what we are having here is two different versions of it. So this is a version that connects to an iPhone. So here you can see the iPhone that's basically just slotted into a holder. And let's start here. So we have a sample that gets illuminated through a light source. The light goes through the sample into an objective. So that's just a couple of lenses that are magnifying the image. And they hit a mirror here. The light gets transmitted over here, hits another mirror, goes into the eyepiece, and the eyepiece, practically where you normally would have your eye and see the image, now goes directly into the camera of the phone. And now you can see the image right here. So this is an image of blood cells. And what's nice about the touchscreen technology, you can now zoom in and look at cells in more detail. You can take a picture, and then you can edit the picture, you can annotate it, you can geotag it, you can send it, you can put it on a blog. And for education, it's great too, because we then worked with the kids, and they had their own little web page, and we did what's called a micro-macro survey. So they actually took them home, so to their own gardens and kitchens, and looked at cat hair and how does a cucumber look and all of that. So they learned not only to do microscopy in their homes, they also learned about how thick does the sample need to be, what can I see. So it was very interactive. Wow. They were very creative, and then they posted this all on a Google map where they live and what they looked at. And so yeah.
So had you any idea when you were sitting in that class in 2006 that all this would come out of it?
No, not really, not at all. But I mean, it's really thanks to all the people. I mean, CellScope is such a great project because everyone has an idea and posts it to you. And we have a lending program in the lab going on. So we had 12 devices that we sent out all over the world to people who were interested, and then they came back with feedback and other ideas for other projects. So this is how this all involves. There's so many people involved by now. So the credit really should go to the whole CellScope team, which I can't even name all the people.
Well, thank you very much indeed for coming to show us today. Finally, what's the plan now? Where are you?
Yeah. So I mean, there is so many branches. So for the education, which is what I'm mostly involved in, is we have two main goals right now. One is with the San Francisco Friends School, where Saber Khan is working or was working. We would like to have a lending program where we build about 20 devices and develop curriculum around that as well, and then lend them out to public schools. So schools who do not normally have access to good microscopy lessons, they could lend out those scopes, and the teachers can learn how to use them, teach them to the kids. And if we have one of the CellScopes for 2-3 kids, that would probably be enough, because what's so nice about CellScope is that it's not such an isolating experience doing microscopy, because not one person can look through the eyepieces and see what they're seeing, but now many people, or a few people at the same time, can look what's on the touch screen. You can talk about it, you can move the sample around, you can change the light. That is one idea. And the other idea we are currently exploring is working with the California Academy of Sciences. They have an after-school program, and they also have already purchased some iPads. So this is why we brought this here as well. So we redesigned it slightly to fit the optics to an iPad version, and it's very visible here. So now you have a bigger screen, it's even easier to see, and you can develop with apps that are already there, some sort of integrated microscopy that kids can use, and they prepare their own samples, and you can look at it live and discuss what's happening.
Well, thank you ever so much indeed for coming to share it with us today. It looks great.
You're welcome. Thank you very much.